We're going to look back at our design problem that we had on the first page there, and we're actually going to solve it. Okay, so now that we have a way using the sine law to solve for triangles that don't have a right angle in them or that don't have an angle of 90 degrees in it, we're going to take a look and figure this out. So now that we can solve the roof problem, we're going to first create a simplified diagram. So we want to figure out the length of both the short rafter and the long rafter. So in this particular instance, it told us that we have a bottom piece, okay, and so we know that the length of the bottom is 12 meters, and we have a short rafter, and we have a long rafter. So there's the base of my diagram, okay. I know that I have three sides. I'm going to call them A, B, and C. Okay, so three angles, A, B, and C. I know that angle B is 80 degrees, angle A is 55 degrees, and angle C is 45 degrees. Okay, so just like we did with triangles and primary trig ratios, we have to name the triangle. We have all three angles named: angle A, angle B, angle C. Now we have to label the three uh, side lengths. Okay, so remember, we want to name the side length the same as the opposite angle, but lowercase letter. So angle B up at the top, side length across from it is going to be lowercase b. We've got angle C over here, so the side across from that is going to be lowercase c. And here we've got angle A, side across from angle A is going to be lowercase a. So we don't know what the length of side C or side A are, but we're going to figure that out. Okay. So in part 2, it says we got to write the sine law as it applies to this triangle and then substitute our known information into the triangle to solve. So we know that the base sine law is A is equal to sine A, which is equal to B over sine B, which equals C over sine C. So the length of side A divided by the sine of angle A is equal to the length of side B divided by the sine of angle B, which is also equal to the length of side C divided by the sine of angle C. In this particular diagram, we have all the information that we need to actually substitute values in. So I'm going to do that now. I'm going to substitute in my values. I don't know what the value of angle of side length A is, but I know that angle A is 55 degrees. So I've got sine 55. And I know that that's equal to the side length of B. So the side length of B is 12 meters, and the angle is sine 80 degrees. Okay. And finally, I don't know the length of side C, but I know the angle of C, so I can write in sine 45 degrees. So I'm just substituting the angles into the equation, just like I substitute the side lengths into the equation. And really, the super important part of this is that I have one complete fraction, one complete ratio, where I have both the number for the top and the bottom. Okay, and that is right here. Okay, having that key, as I call it, will allow us to solve for both side length A and for side length C using proportionality, okay, using our cross multiplying, just like we had done with primary trig ratios earlier on, okay, back in the first unit. So if we move down to part C here, okay, we're going to write and we're going to solve these equations for each of these unknown lengths. So let's solve for side length A. Okay, so side A. Okay, and we know that A is equal to sine of 55 degrees, or A divided by sine of 55 degrees is equal to 12 divided by sine of 80 degrees. Okay, I don't need to worry about C because C is not going to help us answer this particular part of the problem because C is we're missing the C value. But we can use our cross multiplication to go back and solve for what we do have. So using our cross multiplication technique, I can multiply A by sine 80 and 12 by sine 55. Okay. Now again, sine 55 and sine 80 just represent decimal numbers. So don't get scared off by the fact that it doesn't look like a number. Okay. It actually represents a decimal number, and we talked about that back in the first unit. Okay. So we actually have 12 times sine 55 degrees is equal to A times sine 80 degrees. Okay. Now, you'll notice that I haven't converted sine 55 and sine 80 degrees into decimal numbers yet. Okay, and I've done that deliberately. I don't want to convert them until I absolutely have to at the end in order to maintain as much accuracy as I possibly can. So now I got to get my A term all by itself. And on the right-hand side of the equation, the A term is being multiplied by sine 80 degrees. So in order to, the opposite operation of multiplying by sine 80 degrees is actually dividing by sine 80 degrees. So I'm going to divide both sides by sine 80 degrees. And what's going to end up happening is that I'm going to have A, because again, these sine 80 and sine 80 are going to cross out. So I'm going to actually figure out what A is equal to. So on my calculator, I'm going to do what's on the left hand. I'm going to calculate what's on the left-hand side of this equal sign. The left-hand side of the equal sign is 12 times sine of 55 degrees, and that is all being divided by the sine of 80 degrees. And so when I punch that through on my calculator, that gives me approximately, I'm going to round that up to 10. Okay, so to 10 centimeters. Okay. Now, that allowed us to solve for side A. We still have to solve for side B because we haven't done that yet. So if we look back up at our ratio, we're going to use the same ratio. Okay, same key, same ratio, same process. Now I'm going to do 12 divided by sine of 80 degrees is equal to C divided by sine of 45 degrees. Okay, again, I have a complete ratio, 12 divided by sine 80. That gives me a number in both the numerator and the denominator, the top and the bottom of that fraction. So now what I need to do is I need to cross multiply. So I'm going to cross multiply, and that's going to give me C is equal to sine 80, which is equal to 12 times sine of 45 degrees. Okay. Now again, I need to get that C value all by itself. And at the moment, that C value is being multiplied by sine 80. So I need to remove that sine 80 from the left-hand side, and the only way I can do that is using the opposite operation, which the opposite operation of multiplying by sine 80, which is, again, dividing by sine 80. So I'm going to divide both sides by sine 80. And again, I'm going to keep sine 45, I'm going to keep sine 80, I'm not converting them into decimals until I absolutely have to, or if I even actually have to. Okay, so I know that on the left-hand side, sine 80 divided by sine 80, those two are going to cancel out and just leave me with 1. Okay, so I just have C, and then on the right-hand side, if I calculate this, I end up with 12 times sine of 45 degrees divided by the sine of 80 degrees, and that leaves me with approximately 8.6. Okay, so the length then is 8.6. So we can use our sine law in order to solve for unknown side lengths, which is a particularly useful thing, particularly in fields of trades and construction and in surveying and so forth.